Hi, hello, good morning. Welcome to Unique World Education's YouTube channel. My name is Shihabuddin. I'm here a mathematics teacher. So today we are discussing some topics related to grade 11. Mostly we are discussing the question paper or half-yearly question paper conducted by different schools. So today we are taking the question paper from Millenium School. Okay, the coming sections you can see the different schools question papers. If you want, you can suggest your schools. You can just suggest the name of schools here, and if it possible, just upload your question paper here. We can discuss that question paper too. Today we are discussing the questions from the chapter Relation and Functions. So the Millenium School, they already finished and they completed their half-yearly question paper, the half-yearly exam, and we got some questions from relations and functions. So look at here the first question, which is that f of x is x square minus 3x plus 1, and f of 2 is given to f of a, then find the value of a. That's the question here. As a 1 mark question. So we know that f of x is given. So just f of x is given. F of x is equal to x square minus 3x plus 1. Okay, so f of x is given. We want to find the value of f of x. So f of x is equal to x square minus 3x plus 1. It is given that f of 2a equal to 2 into f of a. It is given f of 2a. That means we can find the value of f of 2a or the image of 2a. Just substitute. So we get 2a whole square minus 3 into 2a plus 1. So we know that this is 2a whole square, so we can write 4a square minus 6a plus 1. Then second one, it is given that it is equal to 2f of a. So just find f of a. F of a is equal to, just substitute x equal to a. So 3a plus 1. That's all. Now it is given that f of 2a equal to 2 into f of a. So f of 2a equal to 2 into f of a. F of 2a equal to 2 into f of a. So f of 2a, we found the value. It is 4a square minus 6a plus 1 equal to 2 into, we want to use the bracket, it's very important. So a square minus 3a plus 1. So if you open the bracket, we will get 2a square minus 6a plus 2. So we know that it's a quadratic equation, but we want to write in standard form. So we can write 4a square minus 2a square minus 6a, we can cancel, and it will be plus 1 minus 2 equal to 0. So 4a square minus 2a square, it is 2a square minus 1 equal to 0. So we can solve this quadratic equation by taking this minus 1 to right side. So we'll get 2a square is equal to 1. So a square equal to 1 by 2. It's a quadratic equation. Surely we will get maximum 2 solutions. So a equal to plus or minus square root of 1 by 2. So clearly plus or minus 1 by root. And look at the options. Plus or minus 1 by root 2 is there, plus or minus 1 by 2, plus or minus 1, and plus or minus root 2. So it is plus or minus 1 by 2. Okay. Then look at the next question. What is the question here? Yeah, two functions are given. F of x and g of x is given. We need to find f plus g of 5. It's a simple question because just add the functions. It's algebra of two functions. We know that f plus g by the definition. Okay, by the definition f plus g of x equal to f of x plus g of x. So f of x here, question is that f plus g of 5. So just substitute x is equal to 5. So f of 5 plus g of 5. Clearly it is f of x is equal to x plus 1. So f of 5 is 5 plus 1. G of 5 is 2 into 5 plus 8. So this is 6 plus 10 plus 8. So 24. Just one more question, that's why it's very simple. But we want to use the concept f plus g of x is equal to f of x plus g of x. Oh, what's the question here? In the following questions, a state of assertion is followed. The statement of reason. Okay. So what's the question? Assertion f of x is equal to x square from f is n to n is a function. What's the assertion? F of x is x square. The domain of the function is n, that means natural numbers. The codomain of this function is again the natural numbers. So because here the question is f of x equal to x square. What's the reason? All relations are functions. Obviously it is false. All relations are not functions. All relations are not functions. For example, we can say a relation 1, 2, 1, 3. It is an example. Okay, it is an example. It is a relation from set 1 to set 2, 3. It is a relation. But it is not a function because 1 has 2 images. So obviously the second one, the reason is false. All relations are not functions. So obviously relation, so the reason is a wrong statement. Then what about the function f of x equal to x square? F of x equal to x square. Obviously it is a function. F of x equal to x square is a function because for any natural number we can find n square as an image. N maps to n square. We cannot find 2 squares for one number. It's not possible. So it is a function. So to get the options, both A and R are true. And R is the correct explanation of A. The first one is wrong. Both A and the reason are true. It's wrong. A is true, but reason is false. That's right, that's right. Assertion is true, but the reason is false. So this is the correct option. Option C. F of x equal to x square. And again, moreover, the function here n to n. If you are considering the function from real number to real number, what will be the graph? The graph, it's like a U shape. Passing through 0, 0. It will be a U shape. So clearly we can draw lines like this and vertical lines. It is intersecting one point. So clearly it is a function. Okay. So next question, yeah. X is equal to 3n, b is equal to x. Though this is not from the relation function, it's from the chapter sets. Okay, but again we can discuss. A is equal to, it is given that ax such that x is equal to 3 raised to n, but there is a condition for n Is that less than or equal to 6 and n is a natural number? 3 raised to n. So we can find the set. The elements will in this set we have natural number is starting from 1. So 3 raised to 1, 3 square, 3 cube, 3 raised to 4, 3 raised to 5, and finally it is less than or equal to, so we can take n is equal to 62. Okay, so 3 raised to 1, 3 square, 3 cube, 3 raised to 4, 3 raised to 5, 3 raised to 6. What is the roster form of B? Set builder form is given. We are finding the roster form or tabular form. X is equal to 9 raised to n. N is a natural number. So 9 raised to 1, 9 raised to 2, and there is a restriction, n is less than or equal to 4. So we can conclude with 4 because n is less than or equal to 4. Okay. And what's the question here? Find A minus B. Find A minus B. A minus B means we want to find the elements from A, but it does not belongs to B. Elements from A does not belongs to B. So elements from A, 3 raised to 1. It is not there in B, so we can write 3 raised to 1. Second element, 3 square, 3 square, 3 square. But 3 square means 9, it is here. And again, 3 cube. 3 cube is not there because 3 cube is 27. 27 is here. So we can write 3 cube. 3 raised to 4. 3 raised to 4. 3 raised to 4 is 9 square. So we cannot. It is not possible to write in A minus B. Then 3 raised to 5. What is 3 raised to 5? 3 raised to 5 is not 9 cube, is not 9 raised to 4. So we can include 3 raised to 5. 3 raised to 6. 3 raised to 6 is 9 cube. So it is not possible to write in A minus B. A minus B means elements from A, does not belongs to B. Then what about 9 raised to 4? Here we have a 9 raised to 4. We cannot write 9 raised to 4 because A minus B is the elements from A. Okay. So it is not possible, the 9 raised to 4. So we can close the set. Okay. Then B minus C. B minus C. We want to write B minus C. Elements from B does not belongs to A. Elements from B does not belongs to A. 9 raised to 1. 9 raised to 1. Is it possible to write 9 raised to 1? I'm just calculating all the values because I want to share it again. So look at here, 9 raised to 1, 9 raised to 1. Because we want to select the elements from B. 9 raised to 1, it is not there. Am I right? Is it there in A? Yes, it is there. Look at here, this is 9 raised to 1. 3 square is 9. So it is not possible to write in B minus A. And 9 cube, 9 square. What is 9 square? 9 square is 3 raised to 4. 9 cube is 3 raised to 6. So we cannot write 9 square, 9 cube. It's not possible because it is there in the set A. then the only one element is remaining, that is 9 raised to 4. So we can write 9 raised to 4 here. So this is a minus b and 9 raised to 4. This is b minus a. Okay, if you want, you can write the values. 3 raised to 1 is 3, 3q is 27, and like that. Okay. Look at your next question. Define the modulus function, draw the graph, and write the domain and range. Define modulus function. So what is a modulus function? A function means we want to define the domain first and the codomain. So modulus function, the domain is R, codomain is R. We are defining the function f from R to R defined by f of x equal to mod x. We are using the notation 2 lines, mod x. Then what is the definition of mod x or modulus of x? We can split the function into 2. If x is negative, we want to write minus x. If x is positive or 0, we are using the same element. Confused? Look at here. What is the modulus of minus 2? Modulus means we know that the positive value, it will be 2. So how will we get 2? Actually, we are multiplying a negative with negative 2. That's why we got 2. Then what's the modulus value of the positive? No need to change anything, the value itself. That's why we are defined the modulus of f of x is equal to mod x. It is minus x, and if it is x is less than 0, it is minus x, and positive x if x is positive. Then draw the graph. For drawing the graph, we are just considering some arbitrary values. So mostly we are preferring minus 3 to 3. Here x value, here the function f of x equal to mod x. So we want to start from minus 3, minus 2, minus 1, 0, 1. We want to introduce some more tables here. 2, 3. So modulus of minus 3, we know that negative will be positive. 3, 2, 1, 0, 1, 2, 3. So by using this table, we can draw the graph. For that, we are using x and y axis. And we know that this is x-axis. This is the y-axis. Mostly we are using this x dash and y dash. This is the origin. And 1 centimeter is equal to 1 unit. 2, 3, 4. Minus 1, minus 2, minus 3, minus 4. 1, 2, 3, 4. Actually, there is no negative value in the y-axis, but we are just noting some negative values here. 1, 2, 3, 4. 1, 2. Negative 1, negative 2, negative 3, negative 4. So look at your minus 3 and 3. This is the point, minus 3 and 3. This is minus 3 and 3. Minus 2 and 2, it will be here 1 and 1, 0. So we'll get a straight line. So we want to draw a straight line. passing through these points, we get a straight line. Passing through 0, 0, because 0 is equal to 0. Then again, from here we have the right side. 1, 1, 2, 2, 3, 3. Okay. Then the positive direction. You want to write the positive direction. Again a straight line. There is no confusion. Again a straight line. We want to draw a straight line passing through these points. So why I am writing like this? Because there is no accurate value here. 2, 2. This is 3, 3. This is minus 2, 2. Minus 1, 1. This is 1, 1. 2, 2. And finally 3, 3. Okay, so we want to draw an arrow mark here because it is endless. It is endless. So this is the graph of f of x equal to mod x. F of x equal to mod x. So what's the question? Then just write the domain and range. The domain of this function. Domain means values of x. The domain, values of x. Here it is defined in everywhere. If you are substituting x equal to pi, we'll get the value. If you are substituting x equal to 0, we'll get the value. So for any real number, we can find the image. For any real number, we can find the modulus. Therefore, domain of f or domain of f of x equal to the whole real numbers. Domain of f is whole real numbers. Then what's the range? Range of f of x. Sorry, we have no need to write f of x. Range of f. And domain of the function f. That's it. Because we are denoting f is the function. So domain of f is R. What's the range? Range in values of y. Look at the graph. Look at the graph. Here, the values of y. Yeah, all values of y or all the values of f of x is positive, including 0. Okay, so we can write whole positive real numbers including 0. This is closed 0, open infinity. Mostly we are using open bracket for infinity. So closed 0, open infinity. So this is the modulus function, definition, graph, domain and range. Okay. Then the Millenium School. Yeah, it's an important question. Find the domain and range of the functions. First one, here we have two functions. First one, f of x equal to x square minus 4. Square root of x square minus 4. We want to find the domain and range. First of all, we can find the domain. How we can find the domain? Domain means values of x. Values of x is the domain. So here, f of x is equal to square root of x square minus 1. It's a real function and real valued function. Okay, so all values will be real number. It's not a complex. So for a real number, we know that inside the square root will be positive or 0. So we can write x square minus 4 positive or 0. So that means we can solve this inequality. That means x square, I am taking this minus 4 into right side. So it will be plus 4. X square is always greater than 4. That means again here we have two conditions. First one, x is greater than or equal to 2, or x is less than or equal to minus 2. If x is less than minus 2, that means minus 3, minus 4, minus 5, minus 6, or minus 2.5, minus 3.5, anything. We'll get x squared is greater than 4. And if x is greater than 2, 2.5, 2.3, 5, 3, 7, anything, we'll get x squared is greater than 4. So this is the domain. But we want to introduce intervals here, or we want to use the brackets. Bracket means intervals. X is greater than 2. How we can write in interval form? Equal to is there, so 2, 2. It is greater than 2, so 2 to infinity. Here it is closed, open. Or in set notation, or means the union. X is less than or equal to minus 2. It is less than or equal to minus 2. If you have any confusion, we can draw the number line system. Here we have minus 2 and 2. Less than means this portion. Greater than means this portion. So union, it will be minus in infinity. Here we have negative infinity. Here we have positive infinity. So negative infinity to minus 2, closed. This is the domain of the function f of x equal to x squared. Again, how we can find the range of this function? How we can find the range of this function? Then we are discussing the range. Range means values of y, collection of or set of values of y. So here we know that the minimum value of x is minus 2. Am I right? No. Minimum value of x is minus infinity to minus 2. So we can select any number, any negative number we can consider for x value. So we are finding the values of y. So for that, just consider y is equal to x squared minus 4. So look at here, the domain. We know that the domain of this function is the domain. We got the domain is 2 to infinity union minus infinity minus 2. That means domain is values of x. We can consider x belongs to this domain. So x is 2 to infinity is there. So we can consider x is equal to 100, 1000, crore, anything. So surely if you consider x is equal to 1000, what will happen? Y will be 1000 square minus 1. So by using the values of x, we can find the range. We can find the values of y. So here we can find the values. If you are substituting x equal to 2, what will happen? If you are substituting x equal to 2, y will be 0. Alright. If you are substituting x equal to 10,000, is it 10,000? Yeah. Then what's the value for y? 10,000 square minus 4. I am not going to calculate this value, but in any way, it's the greatest number. It will be greater than 10,000. And square means we want to write 8 zeros. So that means y value will be greater than 10,000, greater than 1 crore, greater than 1 million, greater than 1 trillion. So we'll get infinite. So values of y, that means the range starting from 0 and ending to, is not ending to infinity. Infinity is a concept. It is not defined. The end value is not defined. So starting from 0. So therefore range is equal to 0 to infinity. The second function, look at the second function, 9 minus x squared. 9 minus x squared. 9 minus x squared. We can consider the second function as 9 minus x squared. Look at here, 9 minus x squared. So just consider the function, square root, again square root, again square root, the same concept. 9 minus x squared. So again we are finding the values of x. So we know that 9 minus x squared should be greater than or equal to 0. So we are taking this x square right side, so it will be 9 greater than or equal to x square, or we can write x square is less than or equal to 9. Square of x is less than or equal to 9. That means we have two conditions. X is less than or equal to 3 and x is less than or equal to 3 or greater than or equal to -3. But we can combine these two intervals. -3 less than or equal to x less than or equal to 3. The values of x should be in between -3 and 3. Then only we will get the values of x square is less than 9. If you have any doubt, you can again draw the number lines -3 and 3. If it is -4, what will happen? X square is 16. It is greater than 9, it is not less than or equal to 9. So that's why we are considering the values in between -3 and 3. So this is the domain. You can use, this is an inequality, so we can use the interval. Domain is equal to, we want to use closed bracket because -3 and 3 is included. But then we can find the range. Range means values of y. So here -3 and 3. If you're substituting x equal to 3, what will happen? We will get y is equal to 0. If you're substituting x equal to -3, again we will get y is equal to 0. What will happen if you are substituting x equal to 0? Y should be square root of 9, so we'll get y is equal to 3. So that means the range, the minimum value of y is 0, the maximum value of y is 3. So this is the range. If you want, we can draw the graph of this 9 minus x square. So range is 0 to 3 and the domain is -3 to 3, -3 to 3. So this is a semicircle with radius 3. Okay, so these are the questions we have discussed from the question paper conducted by the Millenium School. So if you have any suggestion, you just give your school's name and the question paper. We can discuss the questions. Okay, so in the coming classes, you can see that we can discuss different schools' question papers. Okay, bye. Thank you.